In my last video, I showed you how back in 2017, I built an information panel using a Raspberry Pi and a custom built frame. And that's been working great for the last 8 years. But now it's time to bring it up to date. I want to replace the screen with a touch screen so I can control the panel that way. And I want to rewrite all of the software to bring it all up to date and make everything more consistent. Let me show you how. Hello once again, Pi geeks and techno nerds all over the world. My name's Jeff, and I'm an IT professional who's been in the industry for over 30 years. I've been using Raspberry Pis since they first came out, and I wanted to share with you some of the projects that I've done along the way. If you like what you see on this channel, please hit that like button, subscribe if you want to see more, and hit that notification bell so you can be told when I put a new video out. Let me know in the comments how you get on with this project, and if you've got any ideas for projects you'd like to see me do in the future, put those in there as well. Now, as you can see, there's been a few changes here in the studio. I had a few comments saying that the green screen wasn't doing me any favors. So I thought I'd get rid of that and just show you my room here in its natural glory. Now, I did also invest in the light back there to keep everything on brand, but let me know what you think about the new look. Now, my old information panel has been working brilliantly, but it is kind of old now, and there are some bits and pieces that just aren't working very well with the latest operating system updates, particularly the push buttons on the front. For some reason, the code that underpins those isn't working particularly reliably. So I'm finding sometimes I'm pressing the buttons and nothing is happening. So this got me thinking, why not revamp the whole thing, rebuilding it around a touch screen and rewriting all of the software so everything runs a lot better. Now, the first thing that I had to invest in for this was the touch screen. So I picked up one of these. It's a really cool monitor that's completely powered from USB, but it also has an HDMI input on it as well. So just as an example, I've got my phone here and I've got a USB cable attached to the bottom of it. Now here I've got the screen, and if I just plug the USB cable in, you'll see it will start to mirror the phone. And there you go. And I can even use the touch screen to actually drive the phone. It's really very cool. And it should work absolutely perfectly with the Raspberry Pi. Now, the one thing I don't want to do with this is just take the monitor as is and just kind of hang it on the wall like that. I think it would look kind of janky. I want to make it look really swishy. And so what I'm going to do is I'm going to take the actual screen out of this and mount it in a photo frame. This way, the screen will be just completely centralized within the frame. There won't be any of the plastic bezel around it, and it should look a whole lot better. But first, I've got to actually be able to take the screen out of it. So let's go and take a look at that. In order to get into the monitor, I'm going to be using one of these. It's a little prying tool that I got with an iFixit toolkit. Where it's plastic, it should mean I won't really scratch up the case and make a mess. But if you've got anything that's relatively thin plastic that's fairly durable, it should work just fine. For instance, an old guitar pick or something like that. But let's go and take this thing apart. So here you can see the monitor just sat on my bench. I'm going to take my pry tool and I'm going to stick that into the bottom edge and then just pull it across. And this will then unclip all of the plastic clips that are holding the bezel in place. I can then go around the 3 remaining sides. Now all the clips are free, I can just lift the bezel away, and that just exposes the screen underneath. Now this just lifts straight out, and you can see here just how thin it is. It's way thinner than the monitor that I used in 2017 on the original project. Now it's held onto the board with a ribbon cable that you can see there. To disconnect that, just lift up the black tab that I'm showing here, and then the ribbon cable just comes straight away. And you can lift the screen out of place. Now that's removed, you can see the main controller board here, and there are 2 connections. This one is a connection to a couple of small speakers that are embedded within the monitor. Now I'm not going to be using those in this project, but it may actually be a cool update to it in the future. The other ribbon cable here goes off to the other side of the monitor, where there's another USB port and some control switches, none of which that I'll need for this project. So to remove the ribbon cable, Just like with the first one, you just release the black tab and then pull the cable out of the way. For the speaker cable, you can just remove the connector, it just pulls straight out. But do make sure you pull on the white plastic, not on the wires themselves, otherwise you could pull them straight out of the connector. And now I have those cables disconnected, the controller board can be removed as it's only held in with 4 small screws. Now for the actual frame itself, I picked this up. It's really very clever. It's a custom-made aluminium picture frame. And you can pick these up online from many different vendors. Each side of the frame just screws in with these little brackets here. So the whole thing comes apart really easily. Just using this small edge as an example, there's a small ridge here at the top, and that just hides away the edge of the monitor. There's then quite a large gap leading down to a shelf at the bottom, and this gives you plenty of room to hide away the electronics. Now, just like with any picture frame, you'll get a mount with it, and this acts as a surround around the picture that you want to show. Now, in my case, I just got this sized appropriately so that my screen could just sit perfectly within it. And this is the end result. It really does look pretty neat. If I turn it around, you can see I'm just holding the screen in place with pieces of masking tape, and that just stops it sliding around. Now again, just like with any picture frame, there's then a backing board that is used just to keep your picture in place. And this picture frame came with one of those as well. I've cut out a small hole here, and that will let the ribbon cable come through. I've then drilled some small 2.5mm holes into the board that I can then feed some small screws into. I've tried to keep them as flat as I possibly could to avoid them digging into the screen. If I turn the board around, you can see that I've then mounted the controller board and a Raspberry Pi 02W onto the back. I've mounted them onto some small brass standoffs, so there's no risk of them shorting with anything. But if I hold the board like this, you can see that they don't protrude too far above the wood. I can then just sandwich the mount along with the screen and the board into the frame to make the final product. Once you've got everything put together, the last slight problem is that the board is actually flapping around inside the frame just because of the depth that the frame allows. To counter this, they provide these little spring clips, and these just push in between the underside of the frame and the back of the wood to make it a tight fit. As you can see there, I'll now get all of the rest of the clips in place. Now all the clips are in place, and I've reconnected the monitor to the controller board. Here from the front, you can see everything looks really neat. Now all I need to do is connect the HDMI port and the USB port from the Raspberry Pi Zero into the controller board, and then we should be able to try it out. So here you can see that I've connected the USB data port from the Raspberry Pi Zero into the USB port on the controller, and I've also connected a small cable from the mini HDMI port on the Pi Zero over to the HDMI port on the controller. So I had to pick up some special cables here. One that's micro USB on one end and USB-C on the other, and the other one that's mini HDMI on one end and full-size HDMI on the other. Now we should be ready to power it on and see what happens. Everything's all booted up and Raspberry Pi OS has started up with absolutely no problem. Now unfortunately my power cable here isn't very long, so I can't really lift up the frame too far. But you can just about see that there's a box on the screen that's talking about the SSH password. And what I can do is actually use my finger to move the mouse pointer to the OK button and then click it. And there you can see that the box has now gone away. So now we've got the Raspberry Pi working. Let's go and take a look at the software that I want to run on it. Now, here I've got VS Code open. And what I've done is written a Flask application using Python to present all of the data that I want the application to show on the panel. Now, I know that there are many different frameworks available for writing web applications in Python. I'm just a big fan of Flask. Don't feel you have to use it though. Use whatever you're comfortable with. Starting with my templates, I have a file here called base.html, and this is the core of everything that I want to show on the screen. And here I've got some JavaScript that will allow a lot of the interactions to work. The first of these is a function that can configure some mouse events. Now where I've got the touch screen here, I'm going to introduce a little bar at the bottom of the display with buttons on it that I can then use to go next month on the calendar, previous month on the calendar, refresh the screen, and reboot the whole device. If I touch one of these buttons, I want the background color to turn red, just so it's absolutely clear that I know what I'm touching on the screen. There's then a mouse up handler that turns the background color back to its natural color, which is a kind of light gray. For each individual button, I then give it an action to perform. And this is in the form of an AJAX call. So it just makes a web request in the background, back into the Flask application, calling a route to perform a specific task. In this case, I've got a route called key press, and that will take particular actions depending on which key I'm simulating. Now you can see in this case, I'm simulating pressing the key P, and that could be used to move the calendar to the previous month. The remaining handlers work in exactly the same way. I then set up a couple of schedules that will cause two of the elements on my panel to update dynamically. The first one is where I have a whole bunch of devices posting status information back to the panel. So whether they go up or down, or they're just registering their status, I want that display to be kept up to date without me having to refresh the screen all the time. And it's exactly the same with the news headlines. I want those to update as well. So I've set up these schedules here where the status messages will update every 10 seconds and the news data will update every 20 seconds. I then have a block of code that's run after the page is fully loaded. The first bit of this actually makes the cursor invisible. I don't want a little mouse pointer showing up on my display. Now, where I set the schedule for my status information and news headlines above, they won't actually perform that task until that first timeout happens. So here, when the page initially loads, I just trigger that data to be loaded. This just makes sure that I don't end up with some empty areas on my information panel for a period of time. I then just call that function above 4 times for the different buttons that I want to activate. Down in the body, I'm still using iframes for the weather data and for my webcams. That just works. I could rework it using div tags rather than iframes. I've just found that to be a bit fiddly, a little bit unreliable, whereas the iframes just work straight away. I know it's not best practice, and if you want to do it differently, be my guest. For the 3 elements in the middle, I just declare these as Flask blocks, and those will be covered by a separate HTML template. Talking of which, this is the template that I render when someone asks for the default landing page. For the calendar, I just take the code that Google gave me to embed in my web page to display my calendar. And this is the block that renders the buttons at the bottom of the page to allow me to go next month, previous month, refresh and reboot. These I tags here are just making use of the Bootstrap icon library. And I just use some of those icons just to make the display look pretty. To render the news headlines, I have this HTML file, and here I just use some Flask nomenclature to iterate over a collection of dict objects that provide all of my news data. Very similarly for the status display, I use this template here, and it just works in the same way. It just provides a basic table, and then for every dict object within my status list, I just make it render the time, the source, the status code, and the message for that particular issue. For the status information, I'm using a SQLite 3 database, as opposed to the separate data files that I used in the original implementation. SQLite is brilliant because it's just a very simple file-based database engine. This Python script is just used to initialize that database. So firstly, I open a data file, schema.sql, and I execute all of the SQL commands within it. The contents of that SQL file are really simple. I just look for a table called status. If it exists, I drop it. I then just recreate it, providing columns for my timestamp, status code, error message, and the source of the data. And by the way, the only reason that's called VPN is because my original use case for this code was to check the status of my VPN connection. I actually use it for different purposes now as well. I should really call that source, but what the heck, that's an optimization. Now, purely for initialization, I was then adding a couple of test rows into that database. I've now commented those out just because I've got a working database now. Within the static directory of the Flask application, I've got a whole bunch of different CSS files, and these just provide all of the style information for each of the different sections of the panel. The main file is infopanel.py. This just creates the Flask application and gets it running. Skipping over the helper functions for a second, I define a whole bunch of different routes. Now, a route in a Flask application is effectively just a URL that you request. So in this particular case, if I just go to the root of the web application, it runs this function here and returns the result. So it just calls my getStatus helper function to get the status information out of the database. And then it calls the render template Flask function to render the index.html template, providing the dynamic data it needs as parameters. This /info/test.php route is used to submit status into the VPN status area. Now I've called it info/test.php purely for backward compatibility. If I changed that, then all of the different PCs and Raspberry Pis that are contributing data into my panel would need to be updated to post into a new URL. This way, they can work exactly as they did before. I don't have to change anything. When that's called, it executes this function here. All of the actual status information is provided as URL parameters. So I just extract those from the request. I get a connection into the DB, and I then perform what's called an upsert into the database. I use the source of the data as the primary key. So I try to insert all of the status information into the database. If information about a given source already exists, then it will hit this on conflict section. And if that happens, I then make it perform an update on that row. This way, I don't have to run two separate queries, with one checking to see if data from that particular source already exists, and one to then either insert or update the data off the back of that. I can do it all in one command here. It's just a handy shortcut. I then commit the changes and close the connection. The next part here is the route to handle a key press. Now I'm using a Python framework here called PI Input or PI Input to simulate key presses on the actual Raspberry Pi itself. I first declare a PI input controller. I derive the key to press from the URL parameter. And if you remember back to the HTML we were looking at earlier, that parameter was just part of the AJAX call. If the key to press was either N or P, I can pass those on directly. So I can just call the press method of the controller class, giving it the key that I want to press, and it will simulate pressing that particular key. Now, things aren't quite so simple for function keys. So if I want to refresh the page, I'm identifying that by passing in the number 5. In my mind, this was just relating to the F5 key, but the PI input library doesn't really support function keys. However, within the Chrome browser, you could also hit the left control key and press R, and this would also refresh the page. So that's what I'm simulating here. Now, equally with reboot, that's not really a key. So I just say if a capital R is provided as the parameter, then I'll actually run on the operating system the user sbin reboot command, and that will reboot the whole Raspberry Pi. The next route is to get the VPN data. Again, VPN is a really bad word here. This should say status data, really. I just have a helper function here to get the status out of the database, and then I render the status.html template, providing it with that data. The /newsData route works in exactly the same way, but for the news feed. Now let's go and take a look at some of those helper functions. GetStatus is really simple. It just gets a connection to the database, retrieves all of the rows from the status table and closes that connection, then just returns the data. Actually constructing that data into a useful form is a little bit more complicated. I firstly get the current time, and then for each status row, the time of that particular status event is stored in the database as the number of seconds since January the 1st, 1970, the Unix epoch. So here, I just convert that into a Python datetime object. I then subtract the status time from the current time to determine how many seconds it's been since that status was posted. And I round that to take out any decimals. I don't really care about milliseconds. Having 1 second precision for this is perfectly fine. I then say, if the status information came in more than 180 seconds ago, but less than 360 seconds ago, I consider that to be a warning. So I want the background of the time element on the display to be shown as yellow. If the status information came in more than 360 seconds ago, to me, that's a fail. So I light that in red. Otherwise, I light it in green. Now, I don't just want to show the number of seconds on the display. That could get quite awkward, especially if nothing's been posted for some time. So here I just do some calculations to say whether I'm actually showing hours, days, minutes, or seconds. And I round to 2 decimal places if I am displaying hours, days, or minutes. I finally check the value of the status code that came in with the message. If that's 200, I say it's great and I light that in green. Otherwise, I light it in red. All of this status information is then handed back to be rendered. If you remember back to my prior video, the news data is provided by parsing an MRSS feed. In this case, I'm taking it from the BBC. Now, fortunately, Python has a library readily available called feed parser, and you can use this to directly parse an MRSS feed. Here at the top of the script, I declare a couple of constants, one of which is the URL to the feed, and the other is the maximum number of stories that I want to display. And here I have the code that actually generates the news list. Using feed parser makes this so easy. I just have to call its parse method with the URL of the feed, and it just does it. Feed is then just an object hierarchy that you can pull data from. So here, I'm just initially pulling some information regarding the feed itself. I then grab the top news items, and I limit that to my maximum number that I wish to look at. For each of those news items, I just extract the headline, the link to it, the description, and the thumbnail, and then I just add it to my list of news items. And this ultimately just gets returned when I'm rendering the template. And that's everything. So how do we go about running it? Down in the terminal area here, if I just move into the Flask directory, the first thing I need to do is create a virtual Python environment. And I can do that with python -m venv venv. Once that's done, I then need to install all of my dependencies. I've provided those as a requirements.txt file. So all you have to run is pip install -r requirements.txt. Now that's complete. I have to provide some configuration information for Flask. So I just have to run the commands export flask_app equals Infopanel, which is the name of my main Python script, and export flask_env equals development. And this just says that I'm running this in a development context as opposed to production. I can then run the Flask application with flask run --host equals 0.0.0.0. By default, it would only allow a browser running on the local machine to access the website. So that's why I specify the 0.0.0.0 so I can access the website from any machine on my network. Now the application's running, let's go and see what it looks like. So here you can see the end result. I've also opened up the JavaScript console on the right hand side so you can see some of the log messages that come out along the way. Here at the top you can see my weather information, calendar being shown below it, some status information, news headlines, my webcam feeds, and then I've got that control bar. If I hit the next button and I hold the mouse pointer down, you can see the background for it has gone red. If I release that, then you can see that the calendar has moved to the next month. Equally, if I hit the previous month button and then I release it, you can see it goes back to February again. If I hit the refresh button, it refreshes the display. And I won't hit the reboot button because I don't want my whole box to reboot here. Now you can see I've not got the spacing quite right between the status messages and the news headlines. I have a bit more space on this display than I did on the original one. The original one was limited to 720p. This one is 1080p. So I've got a lot more room to play with. So I need to reorder how things look a little bit, but you get the idea. And unfortunately, that is where this project has really hit the brakes. You could see the web application running perfectly there on my PC. The problem was when I then tried to run it on my Raspberry Pi. The Pi Zero only has 512 megabytes of RAM on it, and the Chromium browser requires at least 1 gigabyte to run. Now, it will actually let you start up the browser. However, I left it running for over 5 minutes. I still didn't see a single piece of content get rendered, not even the address bar. I even tried increasing the amount of swap space available on the Pi Zero, so we could use that if it ran out of physical memory, although of course that would come with a performance hit as well. None of it worked. Now what I find really weird here is that my original info panel was running on a Raspberry Pi 2. The Pi 02W should actually have more CPU power available to it than the Raspberry Pi 2. Now, even though my Pi 2 does have 1 GB of memory, I don't really get why the Pi Zero is running so poorly. I did try swapping it out with a Raspberry Pi 3, and that had a marginal improvement in that I could actually get the browser to come up. But the end result really looked terrible, and my original implementation actually looked better. Plus, all of the touch controls didn't actually work. I could see that it was registering my touch, the background of the little control changed, and I could see that the right route was called in the background. But for some reason, it wasn't actually changing the month on the calendar or refreshing the page when I hit that. Equally for the reboot button, it did actually seem to try to do that one, but then it failed authentication because the reboot had to be done by root. All of this is solvable, but I need to find out how to do it. So unfortunately, there will need to be one final part of this series of videos, as I won't be able to solve all of that right now. But I wanted to take you through the journey anyway, because it's important that we all show our failures as well as our successes. And here, I know the application works. I just need to find how to get it to run successfully on a Raspberry Pi. So for now, that's it for this video. Once again, if you like what you see here, please hit that thumbs up button, subscribe to see more, and hit that notification bell so you can be told when I put the next video out. Let me know in the comments if you've got any ideas about how to solve these issues, and also about how you get on with this project if you give it a go. If you've got any ideas for other projects that you'd like to see me do in the future, put those in there as well. Thanks so much for watching till the end of this video, and until next time, bye for now.